Okay, everybody, welcome to the 2013 AB uh, AB AP exam. So we're gonna run through this. I will give you tips and tricks, maybe give you the full solution for each question. We'll see. We'll see what I can do right now. Okay, so let's start with question number one. Find the limit as 6 approaches 2. So automatically what you want to do is you want to try to plug in the 2, but because this polynomial looks like it's factorable, we're going to try to factor it. So here we have x plus 3 times x minus 2 divided by x minus 2 times x plus 2. We can go ahead and cancel out the common factors, leaving us with x plus 3 divided by x plus 2. And now you can go ahead and plug in the 2. So we get 5 over 4. If you try to plug in the 2 at the beginning, we would have gotten an undefined answer. So you could also try L'Hopital's. Number 2, find the derivative at x equals 2. Okay, well, let's go ahead and get our derivative, which is 3x squared minus 2x plus 1. Plug in the 2. Simplify carefully. And this gives us 9. Okay, which of the following definite integrals has the same value as this one? This integral looks a little complicated, so we're going to go ahead and do u substitution. Okay, so u is going to be x squared, du is 2x dx, du divided by 2x is dx. So when I take my integral, we're going to have x times e to the power of u times dx. And you know what? Let's go ahead and change the limits of integration. It looks like that's what this problem is going to require. So u is equal to x squared, but if I plug in a 4, I get 16. And then u of 0 is 0. So my integral is going to be from 0 to 16 of x u times du over 2x. The x's cancel each other out. The 1/2 you can pull it out of the integral, and that gives us b. Really careful with this question, because if you don't change the limits of integration, you could think that it's a, but that's wrong, since all we're doing is just trying to set up the integral. Right? The limits must match the variable that we're integrating with respect to. Number 4, which of the following is an equation of the line tangent to the graph of this at the point 1 comma negative 3? Okay, let's go ahead and get our derivative here. So we get 2x minus 3, and we're going to have to do the product rule for this guy right here. So it's the first times the derivative of the second plus the second times the derivative of the first is equal to 0. And because I'm looking for my tangent line, I need to get the slope. So I'm going to go ahead and plug in my point already. Let's keep these matching. Okay, we get 2 minus 3y prime plus 9 is equal to 0. 11 is equal to 3y prime, 11 over 3. That's my slope. So that means I can, well, it looks like it's going to be this one, but let's just make sure. Y equals m x minus x1 plus y1, and the negative 3, you can move it to the other side, so perfect. If g is the following function given by g of x, which of the following intervals of g is decreasing? Okay, that means I'm going to want to find my derivative, find my critical points, and then do my number line. So my derivative here is x squared plus 3x minus 70, set it equal to 0. All right, let's try to factor this guy out. Plus 10 minus 7. Set the factors equal to 0 and solve for x. Okay, there's my critical points. Good, good. Let's go ahead and do the number line. So we're going to want to plug in the numbers into the derivative. Numbers to the left of negative 10, in between negative 10 and 7, and then greater than 7. So if I plug in, say, negative 20, here's my derivative. G prime of x equals x plus 10 times x minus 7. If I plug in negative 20, I know my first number is going to be negative. The second number is going to be negative, which means we get a positive. And then if I plug in g prime of 0, then we get a positive times a negative, which is negative. And if we plug in g prime of 10, we're going to get a positive times a positive, which is a positive. So the function is decreasing between negative 10 and 7. Okay. Before I do number 6, let me just check one thing real quick. Oh, okay, I wanted to make sure my mic was on because it would have been a shame if it was off. Find the antiderivative of this. Okay, well, we have the integral from 2 to 4 of 1 divided by 5 minus 3x dx. I mean, you can do it just by doing the shortcut of u sub, but I'm just going to show you the work. U is equal to 5 minus 3x. We're going to take a derivative. Isolate dx. Okay. Also, we're going to change our limits of integration. U of 4 is 5 minus 12, which is negative 7. U of 2 is 5 minus 6, which is negative 1. So my new integral is the integral from negative 1 to negative 7 divided by 1 over u times du over negative 3. Okay. We're going to take out the negative 1/3. But I'm also going to flip my integral. So I got to make it a negative, right? Well, in this case, a positive. My antiderivative is ln of u, evaluated from negative 7 to negative 1, which is 1 over 3 ln of negative 1 minus 1/3 ln of negative 7. Using the properties of logarithms, we can take the two logarithms and combine them into one by taking the negative 1 and dividing it by negative 7. Oh, also, that 1/3, I'm just going to factor it out. So we have negative 1 over negative 7, which is 1 over 7. And that is still not an answer. Let me check my work real quick, because right now I'm getting 1 over 3, the natural log of 1 over 7. Let's see. Well, okay, I'm going to have to use another property right here. So to get the 1 over 7, well, basically I'm going to try to get the 7 to the top of the numerator, to the top and be a numerator. So we get 7 to the power of negative 1. And using another property of logarithms, I can take the exponent and move it to the front. So that's negative 1/3 ln of 7. Let's see if this answer is there. Oh, that one's there. B. Got kind of tricky. So you might want to know your properties of logarithms. 7. F is the function given by f of x. What is the instantaneous rate of change of f at x equals 3? Oh, simple. We just got to take a derivative. So this is 3x squared minus 12x plus 8. Now we're going to plug in our value, 3, which is 3 times 9, 27, minus 36 plus 8, which is negative 9, 8 plus 8, negative 1. A particle moves along a straight line. The graph of the particle's velocity is shown, okay, where J, K, L, and M are constants. The graph intersects the horizontal axis at t is equal to 0. So we got an x-intercept right here. At K, we got one right there, and at M. We have horizontal tangents at J and L. Whoa. Gotta make sure I touch the graph right here. For what values of t is the speed of the particle decreasing? Okay, so since we have a velocity graph and we want to know when speed is decreasing, that means velocity and acceleration, or in other words, the slope of velocity, they must have different signs. Okay, if they have the same signs, that would mean the speed is increasing. So I'm going to do a quick little number line right here. J, K, L, and M. First, we're going to take a look at velocity. Velocity is positive from 0 to J. From J to K, it's also positive. From K to L, it's negative, and negative once again. Now we're going to look at acceleration. So now we're looking at the slope of the graph. From 0 to J, the slope is positive. From J to K, the slope is negative. From K to L, the slope is negative. And from L to M, the slope is positive. And like we said earlier, right, we're looking for the intervals where velocity and acceleration have different signs. So that means we got the interval from J to K and L to M. There's your answer, C. Okay, so we have the function f of x. Which of the following values of x is f not continuous? Well, first we're going to have to simplify it. X minus 2 cancels with x minus 2. If you make the denominator equal to 0, we get a vertical asymptote. So that means that it's not continuous right here. But since we also canceled out on x minus 2 from the function, that creates a hole, or in other words, a removable discontinuity. So you take your x minus 2, you set it equal to 0, and you get x equals 2. If you take any of the either of these two values and you plug it into the original equation, you're going to get an undefined answer. So negative 1 and 2. That's where f is not continuous. Oh, the vertical asymptote, that's an infinite discontinuity. A particle moves along the x-axis with velocity given by v of t. If the particle is at position negative 2 at t is equal to 0, what's the position of the particle at 3? This right here, that looks like an initial condition to me. So you have to know this formula. F of x equals the integral from a to x of f prime of t dt plus f of a. And we've talked about this formula a lot, right? It's always coming up. So if I want to find the position of the particle at 3, we're going to do the integral from -2 to 3 of the velocity plus your initial condition. Oh, I made a tiny mistake right here. Here we have a -2, and this one right here is supposed to be 0. So first, my antiderivative. We get t to the power of 3 minus 4t, evaluated from 0 to 3, minus 2. So now we're going to do our f of b minus f of a. So 3 to the power of 3 minus 4 times 3 minus 0 minus 2 gives us 27 minus 12 minus 2. 40, 30. That's the position of the particle. So f is this function on which of the following intervals is the graph concave down? Okay, this deals with the second derivative, right? So let's go ahead and find that. The derivative of x will cancel out the integral, but it also has us plug in the variable into the function. So this x creates 2x cubed minus 15x squared plus 36x. My second derivative is 6x squared minus 30x plus 36. We set it equal to 0, but I'm also going to factor out a 6. Hopefully this makes it a little easier. Let's get 5. You factor it out. X minus 3 times x minus 2. You solve the factors. And last but not least, we got to do a number line. A number line for the second derivative. Okay. And whenever I do my number line, I always like using my factor form because that's pretty easy to evaluate. Right? Like let's say you're going to do f of 0. You get 6 times a negative, which is a positive. F of 2.5. We get a negative times a positive, which is a negative. And finally, f of 5. A positive times a positive equals a positive. So in which interval is it concave down? Well, from 2 to 3. Which of the following does the limit as x approaches infinity is 0? So it looks like we have to know which functions grow fastest, right? For the first one, they both go to infinity, but this one is greater because x to the power of 99 is significantly bigger than ln of x. The graph of ln of x is a graph that looks like this, and the graph of x to the power of 99 will, because the power is odd, it's like a cubic function, so it should look like this, and you can see that it's growing significantly faster. So here the limit is 0. Check. Small over big. Small over big is always equal to 0. Okay, the second one. E to the x, ln of x. Technically, they're both infinity over infinity, but this one is the big one. This one is the small one. I already showed you the graph for ln of x. The graph of e to the x looks like this. So once again, 0. Once again, we have infinity over infinity, but in this case, this one's the small one. This one's the big one. And it's when you have small over big, we get 0. And you know what? I just noticed I made a mistake. This one was not 0. This one was infinity or undefined because we were doing big over small. So then the answer is 1 and 3. Okay, which of the following which is not a possible value for f of 2? F is a differentiable function, such as the derivative is less than or equal to 3. Okay. Of the following, which is not a possible value? Well, we're going to assume that the derivative here is 3 because that's the biggest possible value that we can get. So if I do the same formula I talked about earlier, f of x equals the integral from a to x of f prime of t dt plus f of a. I'm using this one because I'm given an initial condition. F of 2 equals the integral from 0 to 2 of 3 dt minus 5. The antiderivative of 3 is 3t in this case, evaluated from 0 to 2 minus 5. Three times 2 minus 3 times 0 minus 5 equals 1. Okay. But that's assuming that f of x is the biggest possible value it could be, right? Like 3. That means it could also be anything smaller than that. So out of all these choices, it cannot be 2 because 2 is still greater than 1. Like, let's say f prime of x wasn't 3, it was like 2. Then the answer that we get right here would be, it wouldn't be 1, right? It would have been 2t evaluated from 0 to 2 minus 5, which is 4 minus 5, which is negative 1. And even though the answer is not here, we're saying that it could be something smaller. If your derivative would be 1, then the answer would be smaller than negative 1, and so on and so forth. By letting f prime of x be the biggest value it could be, 3, we can identify the maximum value f of 2 could be. So it's never going to hit 2. Okay, now we have a piecewise function for number 14. What are the values for a and b for which f is differentiable? Well, if it's differentiable, that means the function has to be continuous. And if it's continuous, the limit as x approaches 1 from the left must equal the limit as x approaches 1 from the right. So you're going to take your x plus b and you're going to make it equal to ax squared. And then we're going to plug in the 1 because that's where the graphs should meet, right? At x equals 1. And you get a. Here we get this piece. Okay, now they're telling us that the function is differential. So that means that the limit as x approaches 1 from the left of the derivative should equal the limit as x approaches 1 from the right of the derivative. We learned this way back at the beginning, like back in October, maybe even September. If a function is differentiable, the slope on the left must equal the slope on the right. And the derivative on the left side, x plus b, is just 1. The derivative on the right side, it's 2ax. Plug in the 1 and solve for a. Step number 1, step number 2. And now that I have a, I can plug it back in so that I can solve for b. 1 plus b is equal to 1/2. B is equal to negative 1/2. There we go. 15. Okay. Let k be the function f for g. What is the value of k prime of 3? First, we have to find our derivative. K prime of x is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So k prime of 3 is g of 3 times f prime of 3 minus f of 3 times g prime of 3 divided by g of 3 squared. 10 minus 2 over 4 equals 2. Okay, find the derivative at x equals 3. Don't forget to do the product rule right here. So y prime equals the first. You know what? Before I do my derivative, remember that the square root of x squared plus 1 is the same thing as saying x squared plus 1 to the power of 1/2. So my derivative is going to be 1/2 x squared plus 1 to the power of negative 1/2, and then you apply the chain rule times the derivative of x squared plus 1 plus the second times the derivative of the first. Now plug in the 3, and we get 15 times 1/2 times 10 to the power of negative 1/2 times 6 plus the square root of 10 times 5. Fifteen times the 6 with the 1/2 makes a 3, and then the 10 is going to go to the denominator, 10 to the power of 1/2 plus 5 radical 10. Okay. Next, I'm going to distribute the 15 to get 45 divided by the square root of 10 plus 5 times the square root of 10. Is this answer already there? Yes, it is. That's D. The limit as h approaches 0 is 2. Which of the following could be true about the value of a? Okay, this right here is the definition of the derivative. We just talked about it in class. Which means here's what it is. It's the limit as h approaches 0 of f of x plus h minus f of x divided by h. So they're telling me to take a derivative, and we have a function hidden in this problem, right? So arc sine is the same thing as saying sine inverse. And that right there is my function, arc sine, right? You see it in both. So f of x is sine inverse of x. And if I take my derivative, I get 1 over the square root of 1 minus x squared. And they're telling me what the derivative is equal to. They're saying the derivative, the slope, is 2. So you take your derivative, you make it equal to 2, and you solve for x. Okay. Let's see. And there's my answer. B. Find the derivative. Okay, this is implicit differentiation. There's chain rule. So really careful with this. So the derivative of ln of u is 1 over u times u prime. the derivative of x plus 1 is just 1. So we're finding the derivative, right? So we got to get y prime by itself. So we're going to multiply both sides by 2x plus y. And then we are going to subtract 2x plus y minus 2. The answer is B. The figure above shows the graph of the function g and the line tangent to the graph at -1. H is the function defined right there. What is the value of h prime of -1? Well, let's start by finding the derivative. H prime of x equals the first times the derivative of the second plus the second times the derivative of the first. And if I plug in my -1, we get e to the -1 times g prime of -1 plus g of -1 e to the -1. Okay. Now, the next challenge right here is to figure out what g of -1 is and g prime of -1 is. So g prime of -1 is the slope, right? And we were given a tangent line, so we can actually figure out the slope by doing rise over run. So here the slope. The rise is -6 and the run is +1. So the slope, g prime, is -6. G of -1 is just the value, which is 3. This is -6 over e plus 3 over e, which simplifies to -3 over e. There it is. Find the derivative. Okay. We already got a problem like this one, right? When you take the derivative and the integral, they cancel each other out. But then we have to plug in the variable. Oh, not into the 1. Just that. ln of 2x to the power of 3 plus 1. Because now our limit, our variable, our limit of integration is more than x. We got to multiply times the derivative of 2x. 2. This becomes 2 ln of 8x cubed plus 1. Don't forget to cube the 2 as well. Okay, we have a graph for f, and we want to find the integral from 0 to 7. Oh, this is pretty straightforward. It's just the area underneath the curve, right? So let's see what kind of shapes we get. We're going to do a trapezoid, and a triangle. But don't forget this area is going to be negative, positive, positive. So a plus b over 2 times the height plus a plus b over 2 times the height minus 1/2 base times height. A is the y value, b is the y value, and the height is the difference of the x coordinates. So A is 1, B is 2 divided by 2 times the height, which is 2. The second trapezoid has an initial height of 2, a final height of 2. Oh, wait, no, let's be really careful with that second trapezoid. That second trapezoid is not slanted. The second trapezoid, it's a regular looking trapezoid. So in this case, this is A, this is B, and the height is that. Oh, really careful, it almost got me. So for the second trapezoid, A is 2, B is the distance at the bottom from 2 to 5, so that's 3, divided by 2 times the height, which is 2, minus 1/2 base times height. The base is 2, the height is 2. I'm not putting a -2 for the height since I already wrote that it was negative. You don't have to double dip on that. So this becomes 3 plus 5 minus 2, which is 6. The function f is continuous, and the average rate of change of f on the closed interval is -3/2. There is no value of c such that the derivative is -3/2 of the following, which must be true. The function is continuous for all real numbers and the average rate of change of f. So you're saying f of 9 minus f of 6 divided by 9 minus 6 is -3/2. But then they're saying there is no value of c such as the derivative equals -3/2. Well, this already kind of is implying the mean value theorem, because the mean value theorem says that the average rate of change will equal to the instantaneous rate of change at some random number c, right, within the interval from a to b. But the function must be continuous and differentiable. And the problem says that it's continuous, but it doesn't say that it's differentiable. So then that means the answer is gotta be E. Okay, I'm not even gonna look at the other ones. This automatically screams mean value theorem. But if for some reason the answer is wrong, I'll take a look at it. F is the function defined by f of x. G of x is the inverse. And the 0.01 is on the graph of f. What is the value of g prime? Okay, some of you already asked me about a question like this. When the functions are inverses of each other, f of g of x is equal to x, and g of f of x is also equal to x. When you take two functions that are inverses to each other and you plug them into each other, like this, everything cancels out except the variable. Now your choice is to figure out which of the two are we going to use, since we're looking for the derivative of g. And let's just try them both. The derivative of the outside, you leave the inside alone, times the derivative of the inside is equal to 1. So there it is. This is the one we're going to use because g prime is isolated. Look, had you chosen the other one, this is what would have happened. The derivative of the outside times the derivative of the inside is equal to 1. So you can see that g prime is not isolated. Here, f prime is isolated. But we don't want that one. So ignore it. Plug in the 1. G of 1 times g prime of 1 is equal to 1. Now we have to figure out what g of 1 is. And we're going to do that by the point given to us. They're saying this point is on the graph of f. So in other words, x and f of x has the point 0, 1, which means that x and g of x, because they're inverses, have the same point, but it's flipped. So g of 1 is 0. Now f prime of 0. Well, we don't have that information, so we're going to have to go get it. The derivative of f is 2 plus e to the x, and the derivative of 0 is 2 plus e to the 0, which is 3. So this tells me that the derivative of g at x equals 1 is 1/3. Okay, 24, we're almost done. Okay, what is the absolute minimum of g? get our derivative. We set it equal to 0, but I'm also going to factor a 6. Then we factor it out. 2x, x. Two numbers that multiply to 1 or -1 would be 1 and 1. But they have to add up to +1. So negative, positive. Set them equal to 0. There's my critical points. Take your number line, g prime, -1, 1/2. Okay. Once again, remember, when you're testing your numbers, I don't want to work with this. That's too complicated. I don't even want to work with this. Factor form is the way to go. A lot of times, not every time. Because if I do g prime of 0, I get a negative times a positive, which is a negative. And if I do g prime of, oh, whoa. This is true, but it goes here. G prime of negative, I don't know, 2 equals a negative times a negative, which is a positive. And if I do g prime of 10, we get a positive times a positive, which is a positive. So where's the, oh, the question was saying, what is the absolute minimum? We didn't even have to do the number line. Sorry, guys. We just needed to test our endpoints and our critical points. But you know what? It's okay, because maybe I can still use what I learned from the number line. Since g is increasing and then it's decreasing, I know -1 is a maximum. And when you get to 1/2, you start increasing. So here we have a minimum. So at this point, I'm not even gonna use -1. We just have to figure out what g of -2 is, what g of 1/2 is, and what g of 1 is, right? We test all the critical points and the endpoints. So if I do g of -2, let's try to do this mentally. 4 times -8 is -32. 3 times 4 is 12, plus 12 plus 1 equals 24, 25, -7. I'm going to skip the 1/2 for now. Let's see, g of 1. Oh, you know what? G of 1 is probably not even going to be a minimum. Look at what the graph did. Right? After you get to 1/2, the graph is increasing, right? It's increasing till you get to 1. So that right there is not even going to be a minimum. But we'll do it just in case. G of 1 is 4 plus 3 minus 6 plus 1 equals 7, 8. 8 minus 6 is 2. See, told you. Now the question is, what about 1/2? Oh man, I think there's gonna be no way around it. 4 times 1/2 to the power of 3. That's gonna be 1/8. Plus 3 times the power of 1/2 squared, that's 1/4. 6 times 1/2 is 3. Plus 1 equals, here, let's zoom in. Equals 1/2 plus 3/4 minus 2. Oh, I should have given myself more space. Let's get a common denominator. 2/4 plus 3/4 minus 8/4. 5 minus 8 equals -3/4. Well, there it is. -7 was my minimum. My absolute minimum. Which of the following is the solution to the differential equation with the initial condition Okay. You guys had a question like this in the FRQ. This is a separation of variables. So we have dy dx equals e to the y times e to the x. We're going to separate the x and the y's. Bring it to the numerator. The antiderivative is e to the negative y times the reciprocal of the derivative of negative y. The derivative of negative y is negative 1, and the reciprocal is still negative 1. That's a lot of words, huh? Let's plug in our initial condition. Negative e to the power of negative. So the y value is negative ln of 4. And the x value is 0. That's negative e to the ln of 4 is equal to 1 plus c. E and ln cancel each other out. So that's your c value. So then we're going to take our c value and solve for y. Here we have to use ln to cancel out the e, ln, but everything here is in parentheses. I'm just going to rewrite it. No, let's not rewrite it. That looks weird. Negative e to the power of x plus 5 multiplied by a negative. Okay, is this answer on the board? Yes, it is. 26. Which of the following is the antiderivative? This looks kind of complicated. I can tell you it's not A, because if you think about taking a derivative, we would have to do a chain rule, right? Like the derivative would be 3/2 times 2/3. And then times the derivative of the inside, which is 3x squared. We get a 3x squared that is nowhere near f of x, so it's not A. It could be B. Let me see. Let me just try something here. If I'm supposed to find the antiderivative of f of x, then the antiderivative would be the integral of the square root of 1 plus x cubed dx. If this doesn't work, I'm going to have to do a guess and check method for all of them and take the derivative like real quick. But there's some that I can already see that it's not going to be it. I'm pretty sure it's not going to be this one. I'm pretty sure it's not going to be this one. I'll tell you why in a bit if my method doesn't work. E looks like it works real quick, because if you take the derivative, the integral cancels, and then the x goes in. So, oh man, I think that's the answer already. Okay, maybe I should just tell you. If I take the derivative, the integral cancels, and then this has to be plugged in. So we get the square root of 1 plus x cubed. But you have to multiply times the derivative of the limit of integration, which is 3x squared. And once again, that 3x squared is nowhere to be found. It's not that. Same idea goes with d. 1 plus x cubed times the derivative of the x cubed. Same issue. But when I do it with e, I just get the square root of 1 plus x cubed. And if you take the derivative of x, that's just a 1. So there's my answer. You know what? Let's just stick with that. Okay, perfect. I don't even got to do this. 27. The height of h of an object suspended from a spring is h of t. What is the average height? Okay. Since they're giving us a function that is height and they want us to find the average height, that means they're saying average value. The formula is 1 over b minus a, the integral from a to b of h of t dt. 1 over 2 minus 0, the integral from 0 to 2 of 16 plus 7 cosine of pi t over 4 dt. 1 over 2. My antiderivative is 16t. The antiderivative of cosine is sine, but we got a chain rule. So we're going to take the derivative of this guy, and we're going to get the reciprocal. So the derivative is pi over 4, and the reciprocal is 4 pi. So once again, that's the trick, that's the shortcut of doing u substitution. But if you don't understand that, you're going to have to go through u sub. 1/2. 16 times 2 is 32, plus 7 sine of 2 pi over 4, or pi halves, minus 16 times 0 is 0. 7 sine of 0 is 0. So we'll just is 0. One half. 32. Sine of pi over 2 is 1. Okay, so 7 times 4 is 28. Multiply the 1/2, that's 16, plus 14 over pi. Is that the answer? Oh, there it is. Okay, last question, right? Oh, yep. The function f is defined by sine and cosine. What is the x-coordinate of the point of inflection? Automatically, I don't even have to keep reading right now. I just need to know second derivative. So my first derivative is cosine of x minus sine of x. The second derivative is negative sine minus cosine, set it equal to 0. You can add either function. Actually, yeah, let's do it. So when does sine equal to cosine? But also, no, when does cosine equal negative sine? So, well, sine and cosine only equal each other at the pi over 4 units, right? At pi over 4, cosine is the square root of 2 over 2, and so is sine. At 3 pi over 4, I mean, look at the x-coordinate, right? We're going to the left, so it's negative. Sine is positive because you're still going up. 4 pi over 4, 5 pi over 4. At 5 pi over 4, they're both negative because cosine is going to the left, sine is going down. And then finally at 7 pi over 4, cosine is going to the right, but sine is going down, so that one's negative. So when does cosine equal negative sine? I mean, just look at my unit circle that I did. Here. But also here. And I'll show you, because if you take cosine of 3 pi over 4, does it equal to negative sine of 3 pi over 4? Well, cosine of 3 pi over 4 is negative radical 2 over 2. Sine is radical 2 over 2, but there's a negative already, so yeah, check. Okay, so we have two critical points. Let's erase this. At x equals 3 pi over 4 and at 7 pi over 4. But these are just the critical points. These are not. We want to figure out where the graph f changes from concave down to concave up. So let's go ahead and do our number line. F double prime of x, 3 pi over 4, 7 pi over 4. Okay, so right now I'm going to be looking at this line right here. So if I do f double prime of, I don't know, say something easy like pi over 2. So I get negative sine of pi over 2 minus cosine of pi over 2, which is negative 1. Now something after that. Let's try pi. Negative sine of pi is 0. Cosine of pi is negative 1. That's a positive. And then something past 7 pi over 4. Since we're going all the way to 2 pi and 2 pi is actually included, I'll select 2 pi. Negative sine of 2 pi is 0. Cosine of 2 pi is 1. That's negative. What is the x-coordinate of the point of inflection where the graph of f changes from concave down to concave up? 3 pi over 4. Okay. So there you go, ladies and gentlemen. As you can see, some of the questions were easy, some of them were a little more challenging, but I'm not asking you to be perfect. Learn as much as you can, right? Make sure you know your formulas, your concepts. Look for those keywords. Start there. Don't overthink it. Just start doing things. I'll see you guys later, and good luck. Good luck with your study.